Hello everyone, my name is Fred, co-founder of Baal, and today we're going to do a code walkthrough of an active learning experiment on CIFAR10. So the goal of today is that we want to enable you to make your own experiment or to use Baal in production as well. So the code is online, it's on our GitHub, so I'll put the link in the description. Feel free to follow along as needed. And today we're going to introduce 4 components of Baal. So first, dataset management, then Bayesian ensembles, uncertainty estimation, and finally, the active learning loop. So first, let's talk about dataset management. So the goal here is really like we need a way to manage unlabeled data from labeled data. Fortunately, Baal helps you in that. So once you load your 2 dataset, so the train set and the test set, you can supply the trained dataset to the active learning dataset, so a structure that will help you managing both states. Here we also disable data augmentation for the unlabeled data. You can instantiate active learning dataset using the pool specific and override some attributes for the unlabeled data. Now that's great. We have a dataset, but there's no label item. So how do we start? Well, we'll just pick at random items to label. This is called the cold start problem, and the most common solution is, unfortunately, to just pick at random. Albeit there are some research that shows that maybe we could do smarter things. So to do that, we simply call active dataset.label randomly with a number. In this case, by default, it's going to be 1,000 examples that are labeled. And then you can start training your model on these. Now we have our data. That was it. So that was pretty easy, right? Now what we're going to talk about is Bayesian ensembles. So Bayesian ensembles are approximation of real ensembles. Their main benefit is that they're very fast and they are close in performance to real ensembles. So to do that, we first need a model. In our case, it's going to be VGG16, but feel free to use the model of your choice. Albeit for today, the model will require some dropout layers, just so you know. Speaking of which, we will make our model ready for MC-Dropout by using the patch module method. So what this will do is that it will always keep dropout activated even at test time. And why do we need that? Well, because we use MC-Dropout. For those who don't know, MC-Dropout is that we're going to do multiple forward pass for each item, and because dropout is activated, we're gonna get different prediction every time. And so this is how we get our ensembles. So now that this is done, your model is ready. Concerning the loss, so the criterion or the optimizer, it's up to you. Baal is agnostic to those, so feel free to choose the one you prefer. Then let's talk uncertainty estimation. In our case, we want to compare the 3 basic heuristic. So first, the random selection, so our baseline, entropy, who compute the predictive uncertainty, and finally BALD, which compute the model's uncertainty. So the predictive uncertainty without the data uncertainty. BALD tends to be a very strong baseline. So I suggest that you start with BALD, and then you can improve your baseline by using maybe Power BALD or Batch BALD, who are more sophisticated version of BALD. So now that this is done, Baal proposed something called a model wrapper. So this is just a utility to help you train, evaluate, and predict using your model and a dataset. Of course, if you have your own framework, feel free to use it. Baal supports Hugging Face, PyTorch Lightning, and Lightning Flash. We have tutorials for those on our website. I'll leave some link in the description as well. So finally, we need to wrap all of this together in the active learning loop. So Baal proposed something called the active learning loop object, who will manage the uncertainty estimation part and the labeling. So this is all done for you, so you don't need to do anything. So what we give it, we give the active learning dataset, we give it a function on how to predict on a dataset, and we give the heuristic, in this case, random, entropy, or BALD. And then some more parameters. And now we're ready for the actual experiment. So you see it was not too bad. It was pretty easy, right? And I'll explain like the actual loop, like what's going on. So what we say by loop is that a step in the loop is when we get a new set of labels. Like what do we do with it? And there's there's 4 steps. So first, we're going to train our data set. We're going to train our model on the new data set. So that's cool. Note here that we reload the initial weights. This is very important. It's been proposed by Yaring-Gal in 2016. And since then, it's very common to reload the initial weights at each step. And then we're going to evaluate our model on the evaluation set, just to keep track of how good we are. And then we will make a step in the active learning loop. So what this will do, this will compute the uncertainty on the unlabeled items and label the most uncertain items for you. So that's pretty neat. And as long as the loop says that we're going forward, well, we just continue. Here, note that we can print the metrics. So we have different metrics for Baal that we propose, but if you're using your own framework, it's very similar. But this is where you would log your metrics into your favorite experiment management tool, like MLflow, weight and biases, and so on. And that's pretty much it. Like, we're done. So when you're done with it, you will get a figure a bit like this. So this is directly from our 2019 paper presented at a workshop at ICML. And here you see we compare BALD, entropy, and random on CIFAR10. And we see in the figure the test loss, BALD is better than entropy, who is better than random. Of course, this is an academic data set. This is very clean. In a real production data, BALD should be much better because there are much more data uncertainty. So there's noise, there's duplicates, there's so many issues in real production data, and that BALD tends to be much better. So that's it on our side. Now, thank you for listening to us. If you have questions, if you have comments, feel free to submit an issue on our GitHub, or you can join our Slack as well. And if you want to talk, we have office hours every week that you can register to. Everything is on our GitHub page, and we also have a beautiful documentation website that can be useful as well. So thank you for following along until here, and see you next time.